morning and good afternoon, everyone. Welcome to another Coffee Break webinar series. My name is Holden Gibbler. I'm an applications engineer for data physics. Today we'll be covering a mixed mode tutorial in SignalCalc 900. Today is August 28th, 2023. The agenda for today, I'll teach you how to set up a mixed mode test. Then we'll also go over the new signal selector features we've made, such as colors and graph or group filters. Here we have our manage tests tab, which we all should be familiar with. The demo for today, I have a Abacus 901. I have one output or drive channel set and one input channel, and I have a BNC cable connected from the input to output. If I want to set up a new mixed mode test, I'll go to test new. I'll click mixed mode. I'll find my controller button and go to mixed mode. Here's where I can apply a template if I had one, but we'll call this MMC coffee break. Okay. So here we have the test tab, which we all should be familiar with. The channels tab. Here I'll configure my 901, so I just have one channel. Coupling, everything looks good here. We'll leave it at default. Here's what we're interested in, is our mixed mode tab. So under the mixed mode tab, we have 5 tabs. We have the reference tab, which lets you configure your broadband random component. We have the components tab, which will let you add components. So we have our sine components, our sweeping sine components, and our narrowband random components. We have our control parameters tab. We have the signals tab, and we have the run schedule tab, which we'll go over in detail. First tab that's important is our broadband random. This is where we enter breakpoint tables. If you're familiar with our random controller, then you know you can add components here. You can delete components using this negative button. You can change the level of the component here, make it a level or a slope component. You can adjust the alarm and abort lines here. You can import an existing reference. You can also rescale the reference here. We also have the spectrum aborts. So this tells us that the spectral lines needed to trigger an abort. So we can increase this or decrease parameter. We also can put this in as a percentage. You have the overall GRMS of all profiles. We have the peak, velocity, displacements, and they're based on 3 sigma peaks. And we can adjust that in the control parameters. If I go to the components tab, here's where we can add or view all of our components. We have 2 by default here. We have 2 narrowband random components between 48 and 60 hertz. We can adjust the min and max frequency by clicking on the component and then looking at the sweep profile. I can increase or decrease the min or max frequencies by typing in a new number here. I can increase or decrease the level by typing in a value here. I can hit apply, and you can see it sloping. I can also drop that down, apply. Also, the great thing about our mixed mode controller is that you can set custom sweep properties for each component and change them. So if I want one of my sine components to be a sweeping sine component, which is here by default, I start at 44 hertz and sweep up to 80 hertz. At this level, I can change the sweep rate from linear to log, and I can also just leave the next component as a linear sweep rate component. So it allows you to customize and have various sweep rates. I can go to my sine component here. So if I want a sweeping sine component, I would look at my min and max frequency here. I edit the parameters here. I can also add new breakpoints here as well by hitting the plus sign. I can add different abort tolerances for each component. So we have the default 3 dB alarms, 6 dB up and down for aborts. I can change the sweep rate again. I can change phase. I can put a number of sweeps. If I want to say 4 sweeps, I'll automatically calculate the duration based on the sweep rate. Or I can just have it sweep infinitely until the test is done. I can choose an initial direction of the sweep. So we can do up or down. So sweep up or sweep down. So starting at the lower frequency bound, and down would be starting at the higher frequency bound and working down. And that adjusts the start frequency parameter here. I can also customize the start frequency location. I can increase this or decrease this, or maybe I want to start in the middle of the sweep there by customizing that. So we enter our H participation and then our start time for our component. And again, these can be different based on the various components. If I want to add a new component, I will click the plus sign and I will go to I can add Sine, another narrowband random, gunfire random, gunfire Sine. In this case, I just want to do a stationary sine wave. So I can set this frequency by hitting the sweep profiles. I'll enter the frequency of this. Maybe I want to do a 300 hertz sine wave at half a G. Leave my alarm abort tolerances constant. I'll hit apply. Now I have a sine component that's not sweeping at 300 hertz. I can then also view, I can look at all my components. I can look at just my selected component on top of my random broadband. I can also look at, I can then select and view the specific component I have selected. I can then do all components without the broadband random, and then just the selected components in this viewing screen. Okay. Those are our components. If I go to my control parameters here, I'm going to skip my stop switch because I'm running on a 901 on a wire. So I can adjust here my FT parameters. I can change the frequency bandwidth and my number of frequency lines. Usually you want to autofill from reference, but you can manually change this if you would like. But I'll leave it at default. Here's our control sensitivity. 0 meaning no correction and 1 meaning faster correction. If I want to adjust faster specific frequency line, I'll increase this or decrease this parameter. The sigma clip is the, if I increase this to 5, I will then see peaks 5 standard deviations away from the mean. Here, so my velocity peaks, my displacements, I have to hit apply for that to apply. There they are. So now you can see the velocity in 5 peak values instead of the 3 sigma. Let me go back here, adjust this. Here's where I can edit my startup time and shutdown time. Here's all my pretest parameters. If you have any questions on the pretest, I highly recommend watching our other coffee break discussing how to configure the pretest. It's found on our YouTube channel. Here's our signals tab. This is where I can set up automatic exports. Then here's our run schedule. So a run schedule here by default, we have this setup of stages and turning on these components here. Maybe I want to customize this. Maybe I want to turn on components at different times and not just all of my components. So maybe instead of doing all here, I want to turn on just my narrowband random components first. So I can go back to my components and look at components number 1 and 2, or my random components, and 3, 4, and 5 are my sine components. So maybe I want to turn on my random components, maybe for some reason at my right after my -3 dB stage. Maybe I don't want to start at 12 dB down. Maybe I want to start at 9 dB down. I can eliminate this stage. I can also customize the duration of each stage. So maybe I just want it to be 5-second stages for the purposes of this demonstration. Maybe you want to sit there at 9 dB for a longer period of time, and you can change that here. You can add the periodic save, which will add a save period associated with each stage. This won't make much sense if you're 5-second stage, but you can customize a save period to say once every 5 seconds, and that's an option for you. But I'm going to turn this off. I can turn on aborts and alarms here. I don't necessarily want my aborts on at my -9, -6 dB stages, but I want them on, of course, for my 0 dB stages, so I'll turn them on. All right, so then I have my turning on here, and then maybe I want to turn on my sine components 15 seconds later. So components 3 through 5. And then I don't want to sweep just yet. And then I want to turn my sweep on for all components after seconds. So we'll do that. So what I'm doing in the run schedule here is I start at -9 dB down and go to 6 dB, then -3 dB. I turn on my narrowband random component. I then jump to 0 dB for about 15 seconds. I then turn on my sine components, which are shown components 3 through 5 here. So I have 2 sweeping sine components, and then I have 1 stationary sine component dwelling at a discrete frequency. And then I go back to my run schedule. I then sit here for about 30 seconds. I'm going to turn this down to just 10 for the purpose of the demonstration, and then 15. And then I'll turn on the sweep. So then now my sweeping sine components will then sweep. So they're starting at 144 hertz and 192, and then sweeping up to the desired frequency here. And then I can go back and then run the entire test with all my components turned on while they're sweeping for 10 minutes. I'm going to turn this down to 2 minutes. We'll do 5 minutes for the first demonstration. Again, you can edit the duration of this here. You can also add a periodic save. By default, we have a 1-minute periodic save for your 0 dB stage. You can edit this to say maybe every 30 seconds. So do it every 30 seconds or 15 seconds if you wish. 10 seconds. Depends on needs are. Okay, so now that it's all configured, I'm going to just double check everything. So I have my random broadband configured, just my default. My channels tab looks good. Everything looks great. We're going to go ahead and hit save. Save. I'm then going to double click the test to bring it into my run test menu. Here's our run test menu. When I hit initialize, I will start the pretest. Go ahead, start. Pretest is finishing. I'll hit pass. My stats looks okay. Means I'm good to go. So I'll hit start. Okay. So here we have our basic mode template on our control. So we have our control, we have our drive, and then we have our time domain data from our input channel. But maybe I want to view my components separately, my sine components and my random components. What I can do is I can add a new graph. I can right click, go to add signals, and we have a lot of different signal types, especially when you have several different channels. Right now I just have the one channel, but you'd have several signal types, and if you had a large channel count. So a good way to organize is going to group name and then viewing these filters here, and I can view. So maybe if I just want to put my sine components on my graph, I could just highlight my sine components 3, 4, and 5, hit close, and then it'll view all of the signals associated with just those sine components. I can then click add all instead of manually adding them with the plus buttons. And this will display all the signals now onto my graph. But as you can see here, the colors, it's going to look like a rainbow, and it's going to be hard for your eye to discern what information is what. We have the colors option here. So if I click apply signal attributes to traces, I'll automatically sort my color defaults to all of the associated signal types. And I can view what the defaults are here. So my abort lines are going to be red. My alarm's going to be orange. My control is going to be dark blue. Reference is lime green. I can change these defaults by clicking on it and changing the color. So maybe I want it to be the reference to be yellow. I can do that. I can also change the width of the lines by default, the style as well. I can also just go back to defaults by hitting defaults. So maybe I want the reference line to be a dash line or a dot line. And then I want to change the width. Maybe I want it to be double what the normal line width is. I can then hit save, hit apply, OK, and they'll show up here. And I easily go back to the colors and click default to always jump back to my factory default settings. But save, I'll hit OK, displace my components here. Here we have the Sine components and the random broadband all on one graph. You can see the sweeping Sine components moving, and you can see the reference lines and alarm lines. You'll see our drive signal here. And then here's our just our Sine components. I can also have manual mode enabled. I can manually turn off and on components as I wish. I'll turn on manual mode. I will then click this component button down here. I could then select components and turn them off or on. So maybe I don't want my narrowband random components to be on anymore. So I'll just hit this little checkbox here and click component, and then watch the level drop to 0. So I just turned off those components. And if I want to turn them back on, it's easy to just hit this button again. And then I'll turn on the components. So they'll ramp back up to normal level. Okay. And then I can also, maybe I want to turn off the sweep of one of my sweeping Sine components. I'll just hit the sweep button. Turn off. If I hit the component button, this will, or if I go down here, this will move the component button back down. And then this sweeping component has stopped moving, and the other sweeping component has kept moving. If I go back, I can then re-enable it to start sweeping again. So I'll hit the sweep button, and then I'll hit the down arrow again. And then now you can see my second sweeping Sine component is now back to sweeping again. So that's an example of the manual mode. You can then also turn off manual mode to disable turning off and on the components manually. All right, so I'll go ahead and stop and end this tutorial. And then we're in the review mode. I can see my different separate saves here. Okay. Again, if you want more information, please visit our YouTube channel. Thank you again. My name is Holden Gibbler. I'm the applications engineer for data physics. My contact information is below if you want to email me if you have any questions. For more information, please visit our website at dataphysics.com. Thank you.